Good day everyone, I'm ALJOSHA, the reporter for the Weather Basics Meteorology, the atmospheric waters. So, what is hydrology? Hydrology is the study of the distribution and movement of water both and below the Earth's surface, as well as the impact of human activity on water availability and conditions. So water covers 70% of Earth's surface. Water is one of our most important natural resources. Without it, there would be no life on Earth. The supply of water available for our use is limited by nature. Although there is plenty of water on Earth, it is not always in the right place, at the right time, and the right quality. Hydrology is an extremely important field of study, dealing with one of the most valuable resources on Earth, water, which is the water. All aspects of the Earth's available water are studied by the experts from many disciplines, from geologists to engineers, to obtain the information needed to manage the vital resources. Hydrologists rely on their understanding of how water interacts with the environment, including how it moves from the Earth's surface to the atmosphere, then go back to Earth. Then, this never-ending movement is called the hydrological cycle or the water cycle, which will be tackled later. The field of hydrology consists not only of studying the nature, distribution, movement of water, it is also concerned with the impact of human activities on water quality and with problems in water management. People use water for many purposes. In their homes, people use water for drinking, cooking, cleaning, and bathing. Many industries have a great need for water. In agriculture, water is used for the irrigation of farmland and for livestock. Water in many dams is used to produce hydroelectric power. The list of human uses for water is virtually endless. So, hydrology is the study of water to disseminate to the humans to sustain life and the other living beings here. So, hydrologic cycle describes a process through which water moves through the Earth atmosphere and water system. Basically, how water is recycled. Let's start with how water gets into the atmosphere. In this topic, we will look at what hydrologic cycle is, what are the gases compose the atmosphere, and explore the various layers of the atmosphere. The hydrologic cycle describes a process through which water moves through the Earth's surface and water system. Basically, how water is recycled. So let's start with how water gets into the atmosphere. First is the evaporation. It's changing the water into water vapor. A gas on average 4 to 7 inches of water is evaporated from the ocean surface into the atmosphere each year. Next is the transpiration. It is somehow like evaporation, but this is the evaporation of liquid water from plant in trees for about 90% of all waters that enters the plant's root system. Sublimation. It is the process where the ice and snow change directly into a gas without changing the water first. Next is condensation. Condensation at high altitudes, water vapor changes into tiny particles of ice or water droplets. Because the temperature is low, droplets come together to form clouds and fog. Next is precipitation. But precipitation was discussed earlier. Let's go to the next part. Next part is the surface runoff. Surface runoff, these to move waters across the Earth's surface into lakes, rivers, and streams. And lastly is the infiltration. This is the act of water soaking into the groundwater supply. So I have a video to show you how the hydraulic cycle works.
Water is essential to all life on Earth. But how is the water dispersed? This animation shows one molecule of water completing the water cycle. Heat from the sun causes the molecule to evaporate from the ocean's surface. Once it evaporates, it is transported into and through the atmosphere, where water vapor condenses, releasing its heat to form clouds. The water molecule might move halfway around the world before it falls as rain or snow. Once on land, it will either re-evaporate, be used by a plant, drain to the water table, or enter a stream. Streams and rivers bring the water molecule back to where it started, the ocean. Soon, the water molecule will begin its journey again. Now you know how the water cycle, powered by the sun, distributes water and heat around the world.
So next is the weather basics. Weather can at times it changes quickly and unexpectedly. At other times, it seems steady and reliable or slow to change. Some weather patterns can cause for concern or even life-threatening, such as severe blizzard causing unsafe road conditions or a lengthy drought destroying crops and leaving people without a water source. In these cases, being able to predict what weather and adjust to it is not only important for comfort, but for the survival as well. So next is meteorology. Science that deals with the study of the atmosphere and its phenomena, especially with the weather. So meteorology is about studying meteor showers and space rocks entering the atmosphere. This is the elements of weather. There are 6 main components or parts of weather. They are temperature, atmospheric pressure, wind, humidity, precipitation, and cloudiness. First is temperature. It is measured with a thermometer and refers to how hot or cold the atmosphere is. Meteorologists report temperature 2 ways, in Celsius or C, and in Fahrenheit or F. The United States uses the Fahrenheit system. In other parts of the world, Celsius is used. Almost all scientists measure temperature using the Celsius scale. Next is the atmospheric pressure. It is the weight of the atmosphere overhead. Changes in atmospheric pressure signal shifts in weather. A high pressure system usually brings cool temperatures and clear skies. A low pressure system can bring warmer weather, storms, and rain. Next is wind. It is the movement of air. Wind forms because of difference in temperature and atmospheric pressure between nearly regions. Winds tend to blow from areas of high pressure where it's colder to areas of low pressure where it's warmer. Next is humidity. It refers to the amount of water vapor in the air. Water vapor is a gas in the atmosphere that helps make clouds, rain, or snow. Humidity is usually expressed as relative humidity, or the percentage of the maximum amount of water. Air can hold at a given temperature. Cool air holds less water than warm air. At a relative humidity of 100%, air is said to be saturated, meaning the air cannot hold any more water vapor. Excess water vapor will fall as precipitation. Clouds and precipitation occur when air cools below its saturation point. This does usually happen when warm, humid air cools as it rises. Next is precipitation, but precipitation was discussed earlier. Let's go to the next part, which is clouds. Clouds come in a variety of forms. Not all of them produce precipitation. Wispy cirrus clouds, for example, usually signal mild weather. Other kinds of clouds can bring rain or snow. A blanket-like cover of nimbostratus clouds produces steady, extended precipitation. Enormous cumulonimbus clouds, or thunderheads, release heavy downpours. Cumulonimbus clouds can produce thunderstorms and tornadoes as well. First is the troposphere. This is the lowest part of the atmosphere, the part we live in. It contains most of our weather, which is the clouds, rain, and snow. In this part of the atmosphere, the temperature gets colder as the distance above the Earth increases by about 6.5 degrees Celsius per kilometer. The actual change of temperature with height varies from day to day depending on the weather. About 7 to 10 kilometers above Earth's surface, and it is highest, which is about 17 to 18 kilometers near the equator. Next is the scales of meteorology. We have the microscale meteorology, mesoscale meteorology, synoptic scale meteorology, and the global scale meteorology. First is the microscale meteorology. It focuses on the phenomena that range in size of a few centimeters to a few kilometers and that have a short lifespan. First is the microscale meteorology. Focuses on phenomena that ranges in size from a few centimeters to a few kilometers and that have short lifespan or less than a day. These phenomena affect very small geographic areas and the temperature and the rains of those areas. Next is the mesoscale meteorology. These phenomena range in size from a few kilometers to roughly 1,000 kilometers or 620 miles. Two important phenomena are mesoscale convective complexes or the MCC and mesoscale convective systems or the MCS. Both are caused by convection, an important meteorological principle. Third is the synoptic scale meteorology. Synoptic scale phenomena cover an area of several hundred or even thousands of kilometers. High and low pressure systems seen on local weather forecasts. Our synoptic scale pressure, much like convection, is an important meteorological principle that is at the root of large-scale weather systems as diverse as hurricanes and bitter cold outbreaks. Lastly is the global scale meteorology. These phenomena are weather patterns related to the transport of heat, wind, and moisture from the top tropics to the poles. Global scale phenomena are weather patterns related to the transport of heat, wind, and moisture from the tropics to the poles. An important pattern is global atmospheric circulation, the large-scale movement of air that helps distribute thermal energy, which is the heat, across the surface of the Earth. Next is the layers of atmosphere. This is the layers of atmosphere: the troposphere, stratosphere, mesosphere, thermosphere, exosphere, and we also have magnetosphere. An atmosphere is a layer of gases surrounding the Earth that is held in place by Earth's gravity. First is the troposphere. This is the lowest part of the atmosphere, the part we live in. It contains most of our weather, which is the clouds, rain, and snow. In this part of the atmosphere, the temperature gets colder as the distance above the Earth increases by about 6.5 degrees Celsius per kilometer. The actual change of temperature with height varies from day to day depending on the weather. About 7 to 10 kilometers above Earth's surface, and it is highest, which is about 17 to 18 kilometers near the equator. Next is the stratosphere. This extends upward from the tropopause to about 50 kilometers. It contains much of the ozone in the atmosphere. The increase in temperature with height occurs because of absorption of ultraviolet or UV radiation from the sun by this ozone. Next is the mesosphere. The region above the stratosphere is called the mesosphere. Here the temperature again decreases with height reaching a minimum of about -90 degrees Celsius at the mesopause. Next is the thermosphere. This lies above the mesopause and is a region in which temperatures again increase with height. The temperature increase is caused by the absorption of energetic ultraviolet and X-ray radiation from the sun. The region of the atmosphere above about 80 km is called the ionosphere. Next is the exosphere. The region above about 500 km is called the exosphere. It contains mainly oxygen and hydrogen atoms, but there are so few of them that they rarely collide. They follow ballistic trajectories under the influence of gravity, and some of them escape right out into space. Lastly is the magnetosphere. The Earth behaves like a huge magnet. It traps electrons, which is the negative charge, and protons, which is the positive charge, concentrating them into two bands for about 3,000 and 16,000 km above the globe, the Van Allen radiation belts. This outer region surrounding the Earth, where charged particles spiral along the magnetic field lines, is called the magnetosphere. Lastly is what composes the atmosphere. As the atmosphere composed of 78% of nitrogen, 21% of oxygen, 0.93% of argon, 0.04% of carbon dioxide, and this is the trace amounts: neon, helium, methane, krypton, and hydrogen. And that's all my report. Thank you.